On today's episode, cargo planes that fly themselves, GM doubles down on EV batteries, and manufacturing roars back in March. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.tv today. San Francisco-based aviation startup Xwing has demonstrated fully autonomous cargo aircraft operation from gate to gate. The company, founded in 2016, has been developing autonomous flight technology quietly, acquiring a Federal Aviation Administration Part 135 air carrier certificate, allowing it to operate charter services in the air cargo market. The test flight used a Cessna 208B, a common commercial aircraft used for short-range light freight operations. The test is significant in that the aircraft not only flew autonomously from point to point, but navigated the complex ground environment at the airport, taxiing around traffic and obstacles autonomously. The test flight took off and landed in Concord, California, and carried a safety pilot on board, although all aircraft operations were handled autonomously. Aircraft control and communications were directed from a ground team. The company's system is called AutoFlight, and it's designed to be retrofitted into existing airframes and can be integrated into existing onboard flight control systems. Like Garmin's recently announced AutoLand safety system, AutoFlight is a combination of navigation software and a sensor suite that announces itself to air traffic control. The successful test suggests that autonomous flight may be ready to move beyond the last-mile drone delivery space hotly contested by package delivery companies and major retailers like Amazon, and into the controlled airspace used by commercial aviation. Now, how air traffic control will handle drone aircraft sharing space with commercial pilots remains to be seen, but the development overcomes a major hurdle in autonomous cargo aviation: the ability to safely share airspace at altitudes and speeds used by current commercial aviation. The human pilot's days, well, they just may be numbered. With the Biden administration's signal that the U.S. will accelerate the switch to alternate energy sources, demand for electric vehicles is expected to increase rapidly. Batteries are a known bottleneck, and to address this, the General Motors and LG Energy joint venture Ultium has announced a $2.3 billion investment to build a second battery cell manufacturing plant in Spring Hill, Tennessee. The new plant will be built on land leased from GM and will feed the Spring Hill assembly operations, formerly the home of Saturn. The 2.8 million square foot facility is already under construction and is scheduled to open late in 2023. The new operation will create 1,300 new jobs. The battery technology used by the consortium is a large format pouch cell designed to be stacked vertically or horizontally inside the battery pack. The systems are designed for flexibility, allowing energy options from 50 to 200 kilowatt hours for applications ranging from small cars to large SUVs. GM applications are designed for level 2 DC fast charging with 400-volt battery packs charging at 200 kilowatts and 800-volt packs for truck platforms at 350 kilowatt capability. The Spring Hill facility is GM's third electric vehicle production operation, joining the existing Orion assembly and GM's extensively revamped Hamtramck assembly complex, now named Factory Zero. The company plans to launch 30 electric vehicles globally by the end of 2025, with two-thirds available in North America. Vehicles will be marketed under the Cadillac, GMC, Chevrolet, and Buick brands. The U.S. manufacturing sector racked up the 10th consecutive month of growth in March, according to the executives reporting in the Institute for Supply Management's Manufacturing Report on Business. New orders, production, order backlogs, and employment all registered growth month over month. However, survey committee members reported severe supply chain issues due to the lingering effects of COVID-19. Both basic raw materials and component parts are supply constrained or have extended lead times, while commodity prices and transportation costs are rising. Critical factors limiting industrial production, according to respondents, are worker absenteeism, part shortages, and difficulties in filling open positions. All of the top 6 industries covered by the report reported strong growth in March: computers and electronic products, fabricated metal products, food, beverage and tobacco, transportation equipment, chemical products, and petroleum and coal. Imports slowed slightly in March due to serious port backlogs, and this was reflected in upward pricing pressure for inputs. A major global issue is the shortage of shipping containers. According to global logistics firm Kuehne + Nagel, there are 4 causes: a reduced overall number of containers in circulation, congestion in ports induced by COVID-caused labor shortages, a reduction in the number of seagoing container vessels available with fewer sailings and idle vessels, plus a shift in trade patterns resulting in excessive container capacity in some ports and shortages in others. The problem is acute enough that some vessels are sailing with empty containers to alleviate the problem. Despite these issues, overall sentiment expressed by industrial leadership was positive, with an optimistic outlook outnumbering pessimism 8-1 in survey responses. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For deeper engineering content, visit engineering.tv for exclusive shows like Manufacturing the Future and Designing the Future, not found in our YouTube channel. Thanks for watching.